Hello, and today we are looking at video number 2, but surprise, surprise, there was a small mistake on number 1, so I just wanted to go over that really quickly. On problem 1C, I realized I forgot to put the 1/2. Mark that to a little typo, apologies for that, but it really should be kinetic energy lost 1/2 m1 plus m2 times m1 v1 over m1 plus m2 squared minus 1/2 m1 times v1 squared. So now that we have that out of the way, time for the big kahuna, problem number 2. Now, problem number 2 is a lot of steps and a lot of work, easily the most work of all the problems on here. So this is going to take a little extra time, and hopefully be patient with me because I am I think I will be able to make it through explaining it coherently, but we'll see. So, solving a circuit. The battery in the circuit shown has a delta V of 24 volts. Each resistor is 10 ohms. Find, first, the power output of the battery. 2. Power dissipated by each resistor. And 3. That the battery's power output is the same as the total power dissipated by the resistors. Okay, so let's break this up into steps because obviously we have a lot to accomplish here. First off, we have to look at the image itself and look at the circuit itself. So we have a 24-volt circuit and a 10 ohm resistor on every single resistor R1 through R5. You can see that R2, 3, and 4 happen to be parallel, while R1 and R5 make up the series circuit. So we may have to split those up later in the future. But let's voyage ahead and look at number 1, finding the power output of the battery. So there are really 3 steps to this. The first thing we have to do is find the total resistance, because before we find the power, we have to know what the resistance is. So our parallel, we have 2 equations to find resistance. There's our parallel equation and there's a series equation. A parallel equation is 1 over the entire resistance is equal to 1 over R1 plus 1 over R2 plus 1 over R3 dot dot dot. So, or another way you could do it, which we learned earlier, is the final energy is equal to R1 to the negative 1 plus R2 to the negative 2 plus R3 to the negative 3. So, uh, R2, R3, and R4, let's solve using the 1 over method. So we have 1 over the resistance is going to be equal to 1 over 10 plus 1 over 10 plus 1 over 10, which is equal to 3 over 10. So we know that since that 1 over the entire resistance is 3 over 10, we know that the actual resistance is 10 over 3. Now for series, look at series. So series is much more cut and dry. You just have your total resistance equal to R1 plus R2 plus R3. In this case, we'll have R2 equal our parallel series because in reality, those 3 make up, if you were to take out all 3 and combine it into 1, we really have just one 10 over 3 resistor. So we can redraw it as you see on the right hand side with R1, R2, and R3. So 10 ohms, 10 over 3 ohms. So this represents again the parallel series, and 10 ohms. So the total resistance for the entire circuit now we have 10 plus 10 over 3 plus 10, which is really 70 over 3 ohms. Okay, great. We have that. Now we need to get back to the power output of the battery. But there's one more step we need. So we have ohms, but we need current. So current. The equation to find current is V equals I times R. That's one of the equations, but this is the equation we'll use because we have both voltage and resistance easily available, and it's just some quick math. So you have 24 volts, as we saw earlier, is equal to the current times 70 over 3. The final current is going to equal 36 over 35 amps. Okay, so let's continue this. Now that we have both, sorry, now that we have both total resistance and total current, we are going to look at the power of the battery, what we're trying to solve here, finally. So another equation, now that we have both voltage and current, we can do power equals I times V. Again, looking back at this problem, just to recap really quickly, we needed the total resistance to find the total current, and we need the total current to find the power of the battery. So that's why we needed to do those two steps before we even got to the power of the battery. So the power of the battery is going to be P equals I times V. That's our formula. So P is going to be equal to 36 over 35 amps times 24 volts, which comes out to roughly 24.686 watts. So part 1 is done. Now part 2. Find the power dissipated by each resistor. Okay, so looking at our equation for this, there are multiple equations when dealing with currents and circuits, but here's the one we have to use for this one. Power equals current squared times resistance. Current is a constant in circuits, so first we have to solve for R1 and R5. By constant, I mean that it's going to be 36 over 35 amps at each time it goes through a series circuit. However, this is not the case when it goes to a parallel circuit. We'll get a little more into this later. But so R1, just using math, P equals 36 over 35 squared times 10 equals 10.58. You're going to have the same with R5 because you have the same current and the same resistance. But now let's look at series, because this is where it gets a little tricky and gets a little different. For parallel series, the current splits into, for this particular parallel series, the current splits into 3 paths at the resistors. And since R2 and R3 and R4 have the same resistance, they also have the same current, believe it or not. So this problem is much easier than a lot of other current problems because we just divide the 36 over 35 amps by 3, and we're left with 0.343 amps going through all of the 10 ohm resistors R2, R3, and R4. So the resistance for R2, R3, and R4 is going to be the same. We're going to have 0.343 squared times 10, which is equal to 1.176 watts. So for R2, R3, and R4, we are left with 1.176 watts dissipated by the resistor. Now finally, to the last part, 3, battery's power output. We have to make sure that that is equal to the total power dissipated, because that is how circuits work. Circuits' power output is always equal to the total power dissipated. So the power of the battery is equal to 24.686 watts, as we found in the first problem, or the first step of the problem. The second step of the problem, we found the power of each individual resistor. Now, to find the total power dissipated, let's just add them up. So that's R1 of 10.58 plus another 10.58, so that's resistor 1 and 5, then plus 3, because there were R2, R3, and R4, times 1.1 watts, and we're left with 24.686 watts. Believe it or not, 24.686 is equal to 24.686. So the power of the battery is going to end up equaling the power of the resistor. So there you have it. That is the end of problem 2. Now, remember, these steps are very, very important. You can't just expect to go to the equation P equals I over V to find the power of the battery. You have to do this step by step. This takes a lot of practice, but over time, I'm sure you'll be able to totally get it. Thank you very much. That is problem number 2. Problem number 3 and 4 are on the way, and I cannot wait to record the rest. So thank you.